Alrighty, so let's finish up these notes. So this is the end of 1.5. I'm going to start, I may have actually started example 5 in some classes, but I'm going to start back at the beginning of it because I'm not sure I even started it in every class. So in example 5, it says, let f of x equal this function, determine the real number of values of x that cause f of x to be the following things: 0, positive, and negative. And we're going to do this using sign charts, which will be a totally new concept for you, but we're going to use sign charts a lot, and you use sign charts a lot in calculus. Like, these are very simple, important things for us to be able to do. So the first thing I don't actually need a sign chart for, I want to figure out what the zeros are. So this is very nicely already factored for me, so I can tell from this that my zeros, x would give me -3 and a +4. Okay? In addition to that, one of the things that we want to notice, even though it's not asking us for that right now, is that this x minus 4 is quantity squared, so we have a multiplicity. My multiplicity is 2, and that tells me something about what's happening on the graph. So if you have a multiplicity, if it's just 1, like the x plus 3, that means at -3 we're just passing through the axis. But if it's more than 1 and it's either even or odd, other things happen. If it's even, then the function is tangent to the x-axis at that point, at that x value. If it's odd, then we have a point of inflection through that point. Okay, so things we need to remember here. All right, so for our sign chart, this is the way a sign chart works, because I want to figure out, without graphing it, when this function is positive and negative. And we can do that with a sign chart, because maybe we don't really care what the actual function looks like. Maybe we just want to figure out if it's positive or negative to apply that to whatever it is that we're doing. So we're going to have a line that's basically like a number line. And on this number line, we're going to put our x values where it is 0. Now, these do not have to be evenly spaced like a number line. I actually encourage you not to do that. Instead of worrying about where it really would be on how far they'd be on a number line, just literally put these two things, and usually spacing them kind of evenly helps. So this is -3 and 4. You want them, they have to be in order, okay, from least to greatest, just like a number line. But as far as the spacing is concerned, none of that matters, okay? So here's what I know. I know that at -3 and at 4, my function has a value of 0. So this is kind of like our x-axis. This is what we're going to think about. Okay, so on the x-axis, at -3 and 4, we have a point because that's when it's 0. Okay? Then we're going to find some test points to figure out if our function is positive or negative. So I'm going to, right up here, these are going to be our test points. So I need a point that is less than -3, but greater than infinity. We don't have to go crazy. My test point is going to be -4. I could have chosen -5. I could have chosen -20. It doesn't really matter. It just has to be between -infinity and -3. Then I'm going to choose a test point between -3 and 4. Okay? Well, the easiest one to do there would be 0, because 0 is between those two. Then I need to choose another test point that's above 4, but less than infinity. So let's go with 5, because again, we don't have to go crazy with this. Okay? Now, all I care about, I don't care about the actual value. I care about when I use these test points, would my function end up being positive or negative? So I'm going to look at this -4 here, and I'm going to think about substituting it into here. If I substitute -4 into here, -4 plus 3 is a -1. All I really care about is that it would be negative. So in that first set of parentheses, I got a negative number. So I'm going to put a negative there. When I substitute the -4 in here, -4 minus 4, that's negative, but then I'm going to square it so it becomes positive. So positive, okay? So I would have some negative number times some positive number, which means that it would be negative overall. Okay? So then I'm going to substitute in 0. When I substitute 0 in here, that first set of parentheses gives me a positive number. I substitute 0 in here, and then I square it, so that's going to be positive no matter what. And then positive times positive is positive overall. Then I'm going to use my last test point of 5, put it in here. 5 plus 3 is positive. And then 5 minus 4 squared is also positive. Positive times positive, positive overall. The actual value doesn't matter because my test points, the actual test point I use, that test x that I use, what it specifically is doesn't matter as long as it's between these. Now I can't use negative 3 and 4 because if I use those, when I substitute negative 3 in here, I get 0. That's the whole point. At negative 3 and at 4, it is 0. But here's what we've decided, okay, that if we think about this line being like our x-axis, right, between negative infinity and negative 3, my function, ooh, that is way too big. Sorry, guys. Change that. Between negative infinity and negative 3, my function is negative, so I'm going to shade down here. And if you're using your pencil, just shade very lightly because you still want to be able to read what you have. And then between negative 3 and 4, my function is positive. Between 4 and infinity, my function is positive. Okay? So now I can answer the B and C part of this. Is when is my function positive? When is it negative? Right? So my function is positive between negative 3 and 4. I cannot include negative 3 and 4 because those are zeros. Right? And 0 is not positive. So it's positive from negative 3 to 4. And then I can't include 4 because it is a 0, but then it's positive again between 4 and infinity. That's when it's positive. My function is negative, starting out here at negative infinity and going all the way to negative 3. Cannot include negative 3, again, because at negative 3, it is 0. So this is what these are my answers here. Now, something that goes along with sign charts is thinking about it graphically, which we looked at kind of briefly on Friday. Okay, so I want to think through what we know about the graphs, and we can actually sketch this, right? In order to sketch this, I need one other piece of information. So I'm going to make a little X and Y axis here. But I need one more thing. I need the y-intercept. Okay? So my y-intercept is when x is 0. So my y-intercept would be y equals, if x is 0, then that first set of parentheses gives me a 3. If x is 0, my second set of parentheses gives me a negative 4 squared. So this gives me 3 times 16, which is 48. Okay, so on my graph, I'm going to put my x-intercepts, which I have wanted, and these you want kind of spaced out. 1, 2, 3, 4, 1, 2, 3, 4. So I'm here at negative 3 and at 4. And then my y-intercept, I am not making a bunch of hash marks. I'm just going to come up here and say, this is at 48. Works perfectly just like that. So then I'm going to plot some points. I'm going to put my zeros on there. I have one at negative 3. I have one at 4. And I have a y-intercept at 48. Okay? And here's what I know from my sign chart. I know that between negative infinity and negative 3, my function is negative. Then it becomes positive, which means I have to pass through the x-axis, right? Then it's positive. I have a 0 at 4, so then it comes back down, and this is why it's tangent there, and it bounces back off because it has to stay positive. So I can sketch my graph here. I got to go through my y-intercept. So I come up through negative 3. I hit my y-intercept. I hit negative 4. I'm sorry, I hit positive 4, and then come back up. And that's what my graph looks like. And we can see that, knowing our end behavior and all that kind of stuff, that between negative infinity and negative 3, we're negative, right? And then between 3 to 4, we're positive, and then we're positive again. Because something else that we know about graphs, okay, is that if the So this is x, and this would end up being x squared. So if I multiplied it all out, I don't have to multiply it all out, but it would be a third degree polynomial. My degree is 3. If my degree is 3, my end behavior models a cubic, which I know looks like this, and the leading coefficient's positive, so I know my end behavior anyway is down, up. And that's what I have going on here, down, up. So I should be able to come up with a sign chart to help me with the positive and negative. I should be able to also be able to just sketch a little polynomial here. Okay? So let's try this again, because we can be asked this in different ways. So this gave me a function. I had equal signs. Now we're going to have a polynomial inequality, so I have to pay attention to what my inequality signs look like. So let's look at example 6. It says, solve the following polynomial inequality that they gave us in the way indicated. So the first thing we're going to do is factor. So I'm going to take this. In order to be able to factor it, I need to set it equal to 0. So I'm going to move everything over to the left. So this gives me x cubed. Sorry, I didn't write that where you can see it. X cubed, let's see, minus 4x squared minus 4x plus 16 is less than or equal to 0, because I moved it all over there, and I have my inequality sign. So now I'm going to factor. So I have 4 terms. I'm going to factor by grouping. Group those, group those. I can factor out an x squared. That leaves me with x minus 4. Then I would factor out a negative 4. That leaves me with x minus 4. And that is less than or equal to 0. So then this gives me x squared minus 4 times x minus 4. And that's less than or equal to 0. I can factor that first one again. And so this is x plus 2 times x minus 2 times x minus 4. And that is less than or equal to 0. So I have it completely factored. I'm going to come up with my critical values. So the critical values, the only critical values we really can find right now and what we're talking about are our zeros. So this would be x equals, and so what this gives me over here, that one gives me a negative 2. This one gives me a positive 2. This one gives me a positive 4. Okay. And we're going to look at this analytically, which means with our sign chart. And then we're also going to look at it graphically. Okay? So here's my sign chart. I make a number line. On my number line, I have negative 2, 2, and 4. And again, I don't care about it being spaced like an actual number line, but it does have to be from least to greatest, or none of this makes any sense. So I'm here, here, here. Okay, so negative 2, 2, and 4. Okay, it's okay if it's not super accurate. When we graph it, we want it to be a little bit more accurate, but this is fine. Then we are going to pick some test points. Okay? So my first one I'm going to pick somewhere between negative infinity and negative 2 is going to be, let's do negative 3. Between negative 2 and 2, let's do 0. If I picked 1, I'd get the same thing as far as, are they positive, negative, that sort of thing. Between 2 and 4, let's go with 3. So we don't have to have a decimal. Then between 4 and infinity, again, let's go with 5. Might as well, there's no reason to make it big and huge. Okay? So here's what I know is happening on the axis, right? At negative 2, 2, and 4, these are zeros. Now that I have an inequality, I'm looking to see this is less than or equal to, right? Less than or equal to. And that means it would include the zeros. If it was just less than and not equal to, then I would put open circles on my number line, but I'm going to put closed circles because it does say or equal to there, since I have an inequality. Then I'm going to, when we test these, we test this into the factored form. Okay, otherwise you have to do a whole lot of work you don't want to do. So my first test point is negative 3. When I substitute negative 3 into here, that gives me a negative number. I substitute negative 3 in here. Negative 3 minus 2 is a negative number. Negative 3 minus 4 is a negative number. So I have 3 sets of parentheses. I should have 3 little signs here when I figure them out. then I know that negative times negative times negative gives me negative overall. Then I'm going to try 0. I take 0 and substitute it in here. 0 plus 2 is a positive number. And here I get a negative number. And here I get a negative number. Positive times negative is positive overall. Then between 2 and 4, I'm using 3. When I put 3 plus 2, that's positive. 3 minus 2 is positive. 3 minus 4 is negative. Positive times negative is negative overall. Then I substitute in 5. 5 plus 2 is positive. 5 minus 2 is positive. 5 minus 4 is positive. That's positive overall. So what I have here then, I can shade. Remember, you're going to shade very lightly if you're using your pencil, because you still want to be able to read what's underneath here. But if my number line, I'm thinking about this is like my x-axis, right? Because I have zeros on the axis. Between negative infinity and negative 2, my function's negative. Then it's positive here. Then it's negative. And then it's positive. And it doesn't always completely alternate like this because it didn't here, right? So let's look back here. What I'm trying to figure out is what is happening when this function, right? Oh, goodness, sorry. When this function is less than or equal to 0. So less than or equal to, this means negative or 0. Okay, less than 0 is negative, and it says or equal to. So this is one of those cases, and I've said multiple times when we think about being opened and closed, we only do that for domain and range and a couple of other things. And in this case, because it's negative or 0, and we weren't just looking for when is it positive, when is it negative, then I can actually include things here. So my function is negative, starting at negative infinity, right? Starting way out here at negative infinity. Never include that. And then it goes until negative 2. Well, at negative 2, it is 0, and I'm including it because of this sign right here. If it was just equal to and I wanted to know just when it was negative, then it would be open. And then it starts being negative again at 2 and going to 4. And again, I am including both of those because this is less than or equal to 0, and we're equal to 0 at 2 and 4. So that's what my solution looks like. Another way to look at this is to look at it graphically, and not by graphing it on a calculator, by graphing it from what we already know about functions. So I found my zeros. So let's see, let's mark these off. 1, 2, 3, well, again, you want this kind of 1, 2, 3, 4. There we go. And then 1, 2, 3, 4. Doesn't have to be perfect, but I'm going with that. And so I care about it here at negative 2, at 2, and at 4. And then I also need my y-intercept, okay? So my y-intercept, I get that when x is 0. So if I get when x is 0, this would give me 2 times negative 2 times negative 4. Let me write that where you can read it. Okay. So we have y equals, it would be 2 times negative 2, I don't think I did that much better, times negative 4. Oh goodness. All right, here's what we're going to do. I'm going to erase that. I'm trying to write too close to the edge here. Y'all probably hopefully already have it figured out. Let me put it down here. My y-intercept is at when y equals, then I have 2 times negative 2 times negative 4. I'm still too dang close. Oh, well, that works. So I know negative times negative is positive, so 2 times 4 is 8, times 2 is 16. So my y-intercept is just up here at 16. I mean, it kind of looks like in the same place as my 48 was over there. That is totally, totally fine. So then I'm going to plot my points. Got my zeros and my y-intercept. This is what I need. Okay? then what I know, so I'm not going to use my sign chart because it's like another way. I mean, my sign chart can help me with this, but I want to think about what's happening here. We know from the beginning that this is a cubic, right? My leading coefficient is positive, so I know that my end behavior models a cubic, so my end behavior looks like this. So I'm starting down here somewhere. And not only that, I have to go through, hit all of my zeros. I have to go through my y-intercept. I look at the factored form here. I don't have any multiplicities greater than 1, so I don't have any points of inflection. I don't have any bounces where it's tangent, none of that. So I can just come up here and say, all right, I know I'm starting down, so I go down. I hit the 16, I come back down, and then I have to come back up. I sort of missed that point, but here's the beauty of this. We can just make that point a little bit bigger. There we go. And this is what my function, not 100% accurate because obviously my y scale doesn't match my x scale, and I have no idea what this relative minimum would be, but I don't care about that right now. Right now, we're trying to figure out where is it positive and negative. Right now, I'm looking at this right here, and when is it negative or 0? So when I look at that, and I can see when I care about negative and 0, it's here and it's here. So then I can write my function and say, or not my function, my solution. My function is negative from negative infinity to negative 2. Do I include that? Yes, because it's less than or equal to, so I want negative and 0. And then I start back over at 2 and go to 4. So my solutions are the same because they should be the same because I'm answering the same question. We can answer it from a sign chart or graphically. But sign charts we absolutely have to know how to do because we will do them with things that aren't polynomials and we won't be sketching things like that. The other thing I want you to see from these is that I could actually sketch this right on my sign chart. Okay, you don't have to, and you can decide whether or not you actually want to do this on your notes. But since I told you, we are looking at this as like the x-axis, okay, without our y-axis. If we start negative here, and I kind of drew it right here and right here, but if I start down here, I know that I am crossing through, it's becoming positive, and then it comes down and it bounces and it comes back up. And you see how that looks very much like what we have over there. Same thing down here, is that it's negative, then it's positive, then it's negative, then it's positive, and it looks something like that. And does it match this graph exactly? No, because I didn't necessarily know how far to come up on this one. But this isn't necessarily accurate as far as how far I go down either. But you still get the positive and negative parts of that curve. Okay, so the sign charts are important. Being able to sketch it's important. Thinking about the end behavior. We're going to start talking about end behavior a whole lot more and using some special notation for that. So hopefully we get all that done. But I want you to think about how these two questions, what's the same about them and what's different. Here I had a function, and it was just f of x equals this, right? And then it asked me, when is it positive, when is it negative? And if we're talking positive and negative, you cannot include them because 0 is not positive or negative. But then if we have a polynomial inequality, you're going to end up with a sign. And you have to know, remember, the alligator eats the bigger number, that here, that this is less than or equal to, that's what this means. If it was just less than and we didn't have this equal to part here, then I would not be including these because it would not be including my zeros. So pay attention to these signs, write down what it's actually asking you for so that you can answer the question correctly. Okay? So spend the rest of this time working on your assignment.